Well, here we are, three examples of improper integrals. But why would each of these be improper? What makes them improper? Well, that one seems easy. The one in the middle, it's going to infinity. That's a dead giveaway. If you see it going to infinity or starting at negative infinity, or maybe even starting at negative infinity and going to positive infinity, it's a dead giveaway. It's an improper integral. How about the rest though? Can I actually plug 0 into this original function? No, I'd be dividing by 0. That's undefined. There's a vertical asymptote at 0, and this function, whatever it does, is somehow going up towards that asymptote. Also on the last one, what's the big no-no? Can't plug 0 in for log. Once again, that's an asymptote also. Now, none of these are going to need to be split, but they do have asymptotes. If it was split, if I was going from negative 16 to 16, then I might have to do it, but that's actually impossible to put a negative number in there. Yeah, those examples aren't great, but you saw the example in the last video. We just didn't do a problem, but I showed a picture of it. Look in the notes also. There's some lovely stuff there. First step, integrate. That first problem is x to the negative 1/4. Now it's x to the positive 3/4. Second step, make sure you plug in the correct number. It can't equal 0, but it can get really close. Make sure you're coming from the right-hand side. Third step, plug in those lovely numbers. Wow, that's a little scary. 16 to the 3/4. I would think of maybe taking the 4th root of 16 and then cubing that before we get our final answer there. And then finally, once you plug those numbers in, you can find that the answer is actually 4 times 8 divided by 3 minus 0. I would say that definitely converges to the number 32/3. Let's take a look at that middle integral. How will we possibly attempt that middle integral? It looks impossible unless we use u substitution. Then this is quite the workable problem here. By the way, I know I should have the absolute value inside the logarithm there, but since e to the x is always a positive number, and adding 1 to it makes it even more positive, I am quite positive that is exactly the way I could write it. By the way, I can't plug infinity in there, but I can plug b in, and b is getting really, really close to infinity. That leaves us with just a couple more things. Plug in those numbers. I know, I still have a limit here. And then algebra-matize it. And yeah, e to an infinite power is going to be infinitely large. I think even a logarithm, which grows really slowly, if you take the log of something infinitely large, you get a really large answer. So big, in fact, I'm going to say that diverges. Finally, for this last example over here on the far right, this is more integral practice than anything else, which is a good thing it's chapter 8. How do you integrate that last one? If you said integration by parts, because you had two different types of functions there, you are correct. So you did u times v minus v du. Somehow we got that in there. We finished putting it together. Now we have to plug in our numbers. Can we plug in 0? No, we had to do it just from the right-hand side. Just a little bigger than 0. 0 is not allowed. It is undefined for the natural log. However, we plug in slightly bigger than 0. We put some numbers in here. And there's the numbers plugged in. Handy dandy, easy to deal with. Look at this. What's the natural log of 1 or any log of 1? Isn't that just 0? So I've got negative 1/4 over here. And over there, that little part, well, that's just 0. But it's the part in the middle that's a problem. I have 0 times something that is negative infinity. Looking at the graph of the natural log, as you get really close to 0, it's negative infinity. So that leaves us with one choice. If you can't take the limit, it's a L'Hopital's rule. Soak that in, and when you realize that this is 0, you have your answer.